Hey, hi guys, this is Akash Verma and you're watching CafeIO. Thank you for joining in today. We are going to be talking about relational algebra and relational databases, and we'll be touching upon a couple of key database concepts. So we'll get started, and the stream should begin in about 3 to 4 minutes once people are joining in. So till then, we are just gonna hold it off, and yeah, we'll wait till then. All right. I will be monitoring the chat. So if you have some questions, comments that you want to talk about, or you just want to fill me in, feel free to shoot it, and we'll go from there. All right. So till then, I'm just gonna be passing some time maybe, and we'll bring up some tools to showcase you how to install and how to set up a database, things like that. We'll also touch briefly upon that, and yeah, once we are at 10 p.m. we'll get started. So we'll search for MySQL Workbench and MySQL database. So this is the Workbench. This is MySQL downloads. Community downloads. All right. Hey guys, just hello for the people popping in. We are just about to start the stream chat. So if there are questions that you want to ask, or if there's something that you want to talk about, feel free to put in the chat, and we'll see how to take it forward right there. Right, just another 2 minutes, and we will start. Till then, maybe you can, I don't know, grab a coffee or whatever you drink at late at night. Okay, so what do we know about databases, right? Let's talk about relational databases, and let's look at some cartoons to begin with. What are relational databases, and really what do they do? And I've often find that looking at cartoons kind of helps us understand things in a relatively easy fashion, and also makes it a little fun. So we will share the screen. All right, so let's see database cartoons. Medical database of useful information 5K. Medical database useless information. Yes, this is very true. This is very true. So guys, thank you for chipping in. People who are joining, we're just looking at some cartoons to begin, and I'm just waiting for maybe to be at exactly 10 p.m. and then we'll start the session. I'll also formally talk about what is the summary of the session and what are we going to touch upon. There's a lot of material that I've already prepared and stuff like that. All right. So relational databases are extremely popular pieces of technology, and let me just give me a second. Yeah. So hi guys, people who have just recently joined. So the key things that we are going to be talking about is a relational databases, and very specifically we'll touch upon logical database design, and we'll look at relational algebra and how that is structured. Just go over the key concepts, and I'll start by talking about the most popular database, one of the most popular database, give you an idea of relational databases so that in the next session we can actually try out what we have learned today in an actual database, kind of connect to a DB, use SQL Workbench and things like that. So without waiting, I'll just begin. And the first thing which I want to start by sharing is the links for the download. I'm pretty sure most of you have already installed MySQL database. Now, when it comes to the world of relational databases, has been very popular, very old. Feel free to use any other database like PostgreSQL, which is very popular, and the corresponding tool like a Workbench is pgadmin. So what we have here is a link for downloading the MySQL Community Edition, and this is a free database. Just to say where I went, you just go to homepage for MySQL, and you click on downloads, and you will have MySQL Community GPL download, which is general public license. and you click on MySQL installer for Windows. This is what it will download the MySQL setup for Windows. Now what I've done already is install MySQL and Workbench in my database. I'll probably uninstall it and upload a separate video for offline viewing in case some of you want to understand how installation is done too. All right, so this is the database. This is the core database, which is the database engine, DB server, where you actually have the databases. And this is a tool which is very interesting, which is called MySQL Workbench, which just allows you to interactively work with a database, right? Visually see what are the tables, fire queries, see a visual database design. For instance, you will be able to, all right, see things like this where you have a lot of tables, actors, and you can group them together. This is logical database design, right? This is actual uh, diagram for the database. It is as close to physical as it can get. It is pretty much has all the details that a physical database design has. All right. I've worked relatively extensively with databases. Close to about first 4 5 years of my experience has been in databases. So if you have questions, if you want to talk about other database products, if you're probably not somebody who's from college and are already experienced user when it comes to databases, please shoot questions in the chat and I'll love to answer them if I can. All right, so key thing again, go and download MySQL Workbench. The link is right there in the chat, and this should get up and running. Key thing to understand: please install the database first and then the Workbench. Kinds of makes it easier for Workbench to detect a database. Vice versa also works. Some of the people who have had installations of MySQL before have commented that SQL Workbench sometimes throws a challenge. All right, so just a tip, not really a big thing. Last and but not the least, what I would also suggest is that you once you have the database and a tool to interact, you need a sample database to practice. And most of us are used to practicing with employee database or customer database or schools and student database. While these databases are great, a lot of complex querying capabilities are not possible with these databases. What I mean is that most of the times the structure of the database is very small, like 4 5 tables and all that, and that usually is not great for practice if you're trying to learn. So if you're a student and if you're trying to start learning databases, this is called Sakila database. I am not sure if I'm spelling correctly. It is S Akila or whatever. But this is a movie database, and I'll quickly show you how to get started with that before I get into theory part of it. Now you just go to the link which I've pasted, or you can just go to Google and or just say Sakila database, and the first link that you will get will be this, which is a sample database. Now MySQL has a lot of sample databases. I kind of like this. Click on installation and it will give you all the details of how to install and work with things, right? It will give you all the setups that you need. There are certain sample files that are populated. So you go to this link where you have another link where they have the actual query files and all that. And you can download this, right? The zip file or TZ file, whichever it is. This is the actual DB file, which has all the insert scripts, select scripts. So you can pick the database actual file from here, which is the fourth link which I'm pasting. And the link previous talks about how to use it. It's relatively straightforward. There's about 3 files that you have, and all you need to do is just execute them, double click on run it in a workbench or something like that. So the first file will create the schema, which is all the tables, and the second will populate the data. Very quickly, I'll show you what this data is about and why am I suggesting this. Now, if you look at this, right, this is a very large database. This database is for movie management, DVD store kind of a stuff, and you have lots of actors, films, stores, text, a lot of different dimensions or relations to play from. All right. Now that's what is this database about, and then you will be able to get some nice queries and stored procedures and functions. So if you are in a whole semester, this is a database which you can use for basic querying and advanced querying as well. So for example, a basic query would be select inventory and you'll be able to get responses, or if you want to insert a rental, you can get that. And we'll in the next live stream, we are going to go much deeper into this. I'm just giving an example in case some of you want to try it. All right. There are some complex queries. For example, if you take a look at this, right, which is final overdue DVDs. And this is a very complex query. I would say one, two, three, four joins across five, six tables, and then there are certain parameters and subquery conditions. So this is a relatively complex query, and if you can get to this level of maturity, it will be great for you as a learner. All right. So that's just a very quick introduction. If you haven't caught what I talked, or if you have joined like right now, I've talked about installing the key tools necessary to actually practice SQL. Gave a sample database, which is this Sakila database. Download MySQL Community Edition free of cost. Install MySQL Workbench, which will help you to work and connect to the database. And how does a SQL Workbench look? I'll probably show that too because I have the installation. Once it pops up, yeah, this is how the tool looks. And oh my bad, I am not sharing the screen. Yeah, so this is how the SQL Workbench looks. It will kind of show you home and stuff like this. So you click on the database which I have, and you'll be able to browse all the databases. Now I have not installed Sakila, but we'll do it live next time. All right. So this is SQL Workbench. Finally, coming back, we've talked about the download of database itself. Download it, install it locally. Use a tool called SQL Workbench to connect to the database, like I just showed, and then install a sample database, which really helps you to query it, because it's very hard to insert rows and records, right? Because you need a sample database, and employee and customer or student databases are relatively small to learn complex scenarios. All right. With that, I will hop over and I will stop my screen share, and I will just go to the core that we want to talk about today, right? So I'm just going to be doing a little bit of whiteboarding, live whiteboarding, and some of the content I've just pre-written to make life a relatively easy. I'm gonna be using white color to write anything which I am doing right now, or maybe I should change the color. I'll use yellow color, which is this color. All right, to talk about anything which is well overwriting on top of the previous content. All right. So the key theme for today is that we want to be talking about. Am I visible? Is my whiteboard visible to everyone? Can somebody just give a quick, I don't know, hi, hello, or confirmation in the chat? There's a lot of stuff which I've picked from books which you are familiar with, and then there's a couple of content which I've added. Okay, I'm just hoping that I'm visible. So we are going to be talking of database design, and the first thing that we need to understand is how and why do we need a database design? What is a database design? What is a logical data model, right? And here's a very simple diagram which you must have seen, right? This is a diagram from your textbook, but we will look at it in slightly more detail. And let's take the example of a Facebook, right? Of Facebook system. And Facebook, a part of Facebook, I would not call entirety of Facebook. So we have people posting, right? People are posting, and other people are probably commenting on that post, right? Which is what is depicted in this diagram. So there's all sorts of communication happening here, right? And I'm just trying to explain why you need to study something, right? Because the understanding the why is very important. So there's all sorts of stuff happening here. Maybe there's a post which was authored by somebody, which is called "It was a great day" at the rate Bob, right? And then there is a user called OLS, David, Kathy, and probably some other text, right? And there's all sorts of relationship. These people are friends. This is a post. The original author, whatever is this post which was written by Alice, she has tagged Bob, so Bob is kind of there. And there's a relationship that we are maintaining, right? There's some kind of logical thinking that is happening. Now, if you go back in time, right, when you're studying in academics, it is important to understand how this notion evolved, and which is what is referred to usually as logical data model, right? So how did we arrive at this flow and not something like a haphazard one, which is the connections are flowing all across? Which is where the whole concept of relational and DBMSs and the algebra part comes in. Not gonna get too much into math. I'm pretty sure you guys have already had a fair share of that in your college. So here's the mini word, which is Facebook. And how do we start, right? The first thing to understand is look at the data requirement. What is a data requirement? Well, a data requirement is simply what do we need to do, right? What are we trying to depict? It is a very simple representation of system like we have right now. For instance, there's 4 or 5 users connected, there's couple of data flowing. It's just a commonsensical thought or a process to how do we capture the data. And then there's other attributes which we can think about when we talk of physical data model, like size, length of query, query complexity, etc. But at a very basic level, data requirement is to understand what are we trying to model, what in the world, what mini world or what process are we trying to mimic. So maybe if this is a process, right? There's a lot of objects around us I'm trying to teach. So maybe this is, we want to do a data model for this. What could be the objects? The camera is an object, right? I'm a person, so I'm an entity. I'm using a camera, which becomes a relationship, right? So the data requirement, understanding of data requirement is important. And then you build up some sort of a conceptual design, which is just put into a map or something. This is a good enough conceptual design, right? There's no formal notation. But when you improve this, you arrive at something which is called a logical design, wherein you have notations, wherein you have constructs and rules and symbols and structures and maybe arrows, direction of arrows, lines, dotted lines, bidirectional lines, etc. Right? So that's what is the importance of a database design. Okay, moving on. This is just from your textbook, and the key thing which I wanted to add in this image is not a lot, but something is, if this is a critical part for you guys to understand, right? We all look in the world where there's a lot of databases, and as students, you have been exposed to maybe Oracle, MySQL, SQL Server, PostgreSQL, I don't know what else. Logical design is used to represent the world, to represent the process, which is independent of the database provider, which means that whether it is Oracle, whether it is MySQL, whether it is Postgres, logical modeling will be independent. Why is it important? It is important so that you don't bring in terminology from a vendor specific into your database model. And this is pretty much the same thing. Now here we have used to arrive at a logical data model, right? Additionally, what you have is when you collect requirements, there's functional requirements, right? For example, it's a bank and there's a database structure that the bank created, a logical model. But when you have to operate in a bank, you have to do transaction processing, right? Which means money has to be deposited, money has to be taken out, and people have to kind of see and manage this, right? It has to be updated, right? So those are called functional requirement. What you actually do, and based on that, you specify high-level transactional requirements or specification, which is fed into physical design. Now try and understand this, that below the dotted line, which is this line, everything that is in physical state is database dependent, which means that your logical schema could be independent of database, but your physical schema will be dependent on the database vendor, implying that there are certain differences. For example, certain databases will call database schema, certain vendors will probably not have some sort of a word like schema, right? It will be called something else. Most of the terminology is correct, it's common. However, there are slight differences between the vendors, and you'll, depending on the vendor you choose, you'll be able to figure it out. Now, what is represented on this side? This is pretty much saying that we'll make a table, we'll make a DB, and we'll go in depth of it. However, this side is basically on the application programming side, which is to say that you build a database. Now what, right? You need to insert money into it, add operations to it. So a programming language is used to interact with data, which is what is called as application program design in this word. And a programming language implements something called as a transaction management or transactional implementation, which interacts with the schema and provides updates to databases. All right. So this is a very high level overview on the logical model. Let's go a little more deeper into the concepts of, well, how these things evolved, how these things started, right? And the key thing to start is when there were no databases, right? Remember, let's go back to maybe 1960s or 70s when Mr. Cott decided to create relational databases, right? So there were no databases, there was no concept of a table, and we need to keep the understanding we have aside for a while in order to appreciate what we are trying to study. Because most of the time when databases are taught, it's half algebra, half table, and it's all mixed match. Now, I think it's good to learn what existed before in a concise fashion and then move forward to the physical form of stuff. So we are going to look at the keywords. Entity is just a thing or an object, right? When we talk of ER diagrams, entity is just a thing or an object. What is a thing? Means anything, like a person can be a thing, or an object like a camera, as I was talking about. Entity sets are group of entities, for example, group of people, or in a more common sense way, employees, like a group of employees are entity sets. Relationships between entity are effectively, let's say that I as a person has certain attribute in an organization. I belong to a certain department. Now, this belonging nature is an attribute for me, right? And these are in turn related to other entities, which could be department. So the idea between relationships is that I have a adjective, I have an attribute, which is another entity, right? For example, or I could be having a trait which is another entity, right? For example, I'm holding this pen, right? This pen is something which I have. It's something which I know about. But this pen could itself come from an entity set, which is class of pens, right? And it's important to think of in this way instead of tables, right? Think of it in more real world object instead of tables and whatnot. All right. Now comes a very simple way of depicting this, right? And I'm sure most of you have seen it. This is actually not an ER diagram, it's a class diagram, which is more popular than a logical diagram or an ER diagram because it effectively tries to mimic that, additionally trying to provide operations, which is very helpful, right? So here what you have is traditional employee setup. We have an okay, my bad. Employee who works for a department, which is a one-to-one relationship, right? And then there are operations like add employee, count the number of employee, change a manager, and things like that. Now, an employee is dependent, probably has a dependent, and it could be husband, wife, whatever, could be children, parents. A department and employee, they kind of department can have multiple projects like star, and an employee typically works on multiple, one employee can work on multiple projects, which is the idea, right? And then that's the notation. Below you have all the operations. So this is a class diagram. Remember when I said when you get into logical and try to transpose it into physical world, you have application programming and things like that. And that part, okay, vum.today. I'm not sure what that means, but if that's a question, please retype. So that's the whole idea about let's say a class diagram. It's a structure, it's a fixed structure, which means that there's a fixed notation. And in order to be able to, let's say, learn about UML, I can just probably refer here. I'll quickly share a link which can create and help you create UML diagrams. It's very which is the one? Yes. So this is a relatively easy tool, which is Visual Paradigm, and you can just find a free way to create UML, and it will give you all the structures that you need to create a UML diagram, right? There can be multitude of other free tools as well online, and Creately is good. You can design this even in one of the very popular designing stuff. I'm sorry, there's a video playing. I'm gonna stop it. All right, so that's basically just a little bit on UML. Now, okay, where did it go? Cool. All right, coming back to my notebook. So that's basically a small introduction to or a transition from ER to logical come class diagrams. If you remove the operations, it loosely becomes a logical ER diagram. All right. Now comes a little more in-depth information about relational data model. And so far I've tried to avoid using the term table, but we might start to use it now. Now, what is a relational data model? In good old days, probably around 1960-65, there was a person called Mr. Cord. I don't remember his full name, but he's thought to be the creator of relational databases, like father of relational databases. Now, Mr. Cord realized that there needs to be a structure, or there needs to be a way, a framework that can help us save information and also allow operations on top of that. What it means is, when you try to save something, there has to be a structure, and it has to be a generic structure which can just stay by far and large. It has to be like a framework. For example, object oriented design is a framework which you use in programming. So in databases, you needed something, or that time it wasn't even databases. You needed something which could store data and effectively try to come up with some sort of a ways to work with them, right? Now, why only this way, and why are we studying relational data models? Are there other data models? There are. You have NoSQL data model where there is no fixed structure, where the hierarchy is not flat, where you have a, well, JSON kind of a structure. You have graph databases where there is a lot of connectivity, interconnectedness there. You have key value databases. You have like hierarchical databases where you store hierarchy, right? Different types of databases exist, right? So what do we now need to know about relational data model? A database effectively is a collection of relations. What it means is, and we'll slowly look at the definition of what is a relation and what effectively are we talking about. And around the word relations is the whole relational algebra rotates or moves around. Relations effectively resembles a flat file of records, simple linear structure. So if you open a notepad, type something with equal spacing, 20 character, 20 character, that becomes a relational structure. It can be looked as a table of values, but table was a relatively newer term. All right. Now comes a little bit of notation around it, right? What is a table? A table is loosely the name for a relation. Why do I say loosely? Because this is not an old definition. It was before it was called relations, right? Tuples are effectively called rows. So values inside tables are called rows. Columns are attributes, right? So you have relations, which is effectively tables, and we'll look at a mapping. You have attributes, which are column, and you have rows. Now comes a thought as to how do we work with that, right? How do we understand and select a part of it, or select a certain number of rows or certain number of attributes, right? And in order to do that, relational algebra was established. So a relation is more formally defined as R, which stands for relation, A1 through AN, which is the basically the attributes inside. And the number of attributes it has is called a degree of the relation. Is there something else? Yeah. So just to probably add to this, and this is the what started on the left hand side and what we currently know them on the right hand side. So a relation is a table, attribute is a column, right? So column and table. A domain is a set of all the values inside. Now, if I take a table, if I make a table right now, all right, or a relation R, this is a relation, and let's say there are 1, 2, and we'll call them A, B, C. 3. There are 3 attributes here, or 3 columns. Now there could be 1, 2, 3, and 4 rows here, right? The rows are called tuples, right? And why is it called a tuple? Why is it called relation? It's best to park that now. A better thought would be to, when you study the SQL queries, these things automatically make sense. So a way to understand is, this time we are looking at understanding the concepts from a mathematical or from a computer science perspective. When you try to understand relational algebra, it's relatively easier to just query and then understand, oh, this is what is called a pi operation or a transpose operation. All right. Now, when we looked at all of these values, which is this, so 3 cross 4, 12, there are 12 values that are domain, which is to say that the domain of this relation is 12. This specific relation. Now, there could be multiple relations, which is called a database. There could be another, right? A tuple is a row, as we talked. Now, a schema is a table definition, which simply means that the number of attributes and the names of those attributes and the type it has. Now, type is a concept which is very popular these days. Previously, there used to be just very primitive types, right? There's just text and numbers. Now you have all sorts of types like char, varchar, float, int, intate, signed, blobs, clobs, etc. Right? But the important thing to understand is it's just attributes. You're trying to type something or write something and give it structure. So domain is all value, tuple is rows, schema is definitions, right? Now comes a little bit of words which are usually exam oriented or things like that. Degree of relationship. What does it means? That a relationship is said to be of a certain degree depending on the number of columns we have. So if there are 20 columns, it would be a relationship of 20 degrees. So R20. Cardinality of a relation, and cardinality is a word which is not used these days. You just say the select count star in the table. What you are effectively trying to do is cardinality. But these days, it is not that important. The number of rows are very high, right? So you are not really worried about that because modern databases are very popular. Previously, the number of rows as it increased, the complexity and query increased. So cardinality kind of helped to manage and understand how the query is or how the relationship is complex, how the relation is existing. Now, if you just strike off all of these, you would get modern relational databases where you have table, column, rows, definitions, schemas, etc. A couple of things to understand in the relational structure, which formulates a very foundation to relational algebra. Table name is unique, which means that in the given set or in a given schema of things, in a given schema, in a given database, the name of the relation is going to be unique. So there can be no two relations in the same database with the common name, right? Next comes is what is foundational, probably, okay, not this one, yeah, this one, these two. Each column is distinct, which means each attribute in the database is supposed to be distinct, which means that every column is depicting about something. It's not shared, it's not duplicate, it's unique. Similarly, each tuple, which is each row, is unique, right? And we now know that there are keys and constraints that help us build this, right? Also, each cell is only filled once, which is to say one cell will have a singular value. Now, with some of these understanding, we'll just add something on the fly, right? So now we have looked at relations and we have looked at that multiple of them can exist. Let's say this is R1 and this is R2. Now, there's an attribute A here and there's another attribute A here. While relational algebra say that table name is different, attribute is unique, however, a relation can exist between them, which is what we call as keys. Now, keys can be of a lot of different types. They can be a primary key, secondary key, you can have a foreign key, you have a composite key, and then there's indexes and all that, right? Which is a conversation for a later time. So keys help in defining the relationships in relational algebra, all right? There's another concept which is called constraints. Now, constraints are effectively what you use to control your transaction management behavior, which is to say, in order for a relation to make a change, a certain criteria on a certain attribute must be fulfilled. For example, if I want to update my balance in my account, there has to be a transaction in the transaction table. I cannot just update the balance without having either a withdrawal or a deposit or some kind of transaction. Now, these rules are influenced or designed by using keys and constraints, where you can set conditions in databases which tells a DB engine that, all right, I'm going to be making an update. So once this update is finished, automatically make this change, right, on cascade. And there can be multiple things to do on cascade. For example, you could be doing on cascade delete, you could be doing on cascade update, and things like that. So when you look in the Sakila database, which I talked about, you will get a lot of understanding about this, right? So that's fundamentally what we wanted to talk today. I'll quickly summarize. We have looked at how to start a database, install the database, work with SQL and all that, and install it. And the next session, we are going to be doing a good in-depth overview of this database, and we'll be looking at some complex query scenarios. Second, we looked at a little bit of introduction onto relational model and logical database design, how it works, how it starts, and some of the theory behind it, not so depth. However, the key thing to remember in all of the discussion would be this. So we'll just give a refresher again. A relation is a table, attributes a column, domains are all values, tuples are roles, schemas are table definition, and then degree of freedom and cardinality is number of columns and rows. Now, a very simple tip. When you're approaching your exams, right, don't approach questions which are very theory driven or relational algebra driven from the concept of tables or MySQL or Postgres. Try and understand and imagine that this is a completely separate thing that you're studying, and then try and remember the concepts. For examples, when you try to build pies or projections of a table, which is effectively just saying a select statement, don't think in form of a select statement first. Try and understand if you can do that in the form of algebraic notation and find a subset. If you're not able to, then the next step is to validate that with select. If you are able to, then select helps you in validating that idea, validating your answer in the exam. This is relatively simple, but it can probably help you out. All right. So with that, we will probably take a pause today. If you guys have not subscribed to my channel, please do. Please tell me what you want to listen about more. Do put that in the chat. If there's a topic you want me to touch upon, cloud, data science, machine learning, more in-depth databases, which we'll do next week, please do tell that in chat. Till then, stay happy, stay healthy. Bye-bye.